Next, we're going to learn how to divide when we have exponents on same bases. So the first thing we need to do is think through what each of these represents. So for example, 3 to the 5th, what does that mean? So that means that we have 5 3's being multiplied together. So we could write it out as such. 3 squared, what does that mean? It means we have 2 3's being multiplied together. So 3 to the 5th divided by 3 squared means all of this that I have just written out. So what does it mean every time we have 3 divided by 3? Or what does that equal? Doesn't that equal 1? Well, whenever we have a bunch of multiplication in the numerator of a fraction and a bunch of multiplication in the denominator, we can basically cross-cancel or simplify. It's just like if I had 2/3 times 6/4. I know I can cross-cancel here. That's because 2/3 times 6/4 is the same thing as 2 times 6 over 3 times 4, which is the same thing as 6 over 3 times 2/4, which is the same thing as 2 over 1 times 1 over 2. So you get the idea. Anytime you have numbers that are being multiplied in the numerator and numbers that are being multiplied in the denominator, you can simplify and you can cross-cancel. So here I'm showing you simplifying. So that actually equals 1. So we're going to use the same basic idea. Anytime we have a number divided by itself, that actually equals 1. So the numerator is actually going to end up being 1 times 1 times 3 times 3 times 3, and the denominator is going to end up being 1 times 1. And when I simplify this, how many 3's will I have left in the numerator? How can I express that? With an exponent. So we have 3 to the 3rd. In the denominator, we just have 1. 1 times 1 is 1, so that's just 3 to the 3rd. So 3 to the 5th divided by 3 squared equals 3 to the 3rd. Take a second and look at that. Make sure you understand why it equals 3 to the 3rd. You can think about it as we're going to take these 2 3's away from these 5 3's, so we're left with 3 3's. Do you see any type of operation that's happening? Remember, operation is add, subtract, multiply, or divide. So just think about that for a minute as we go through. Let's test any ideas that you may have. So y to the 4th. I'd like you to think about what that equals. That equals 4 y's. And then in the denominator we have 1 y. Do you see anything we can cancel? Cancel meaning we can divide to equal 1. Y divided by y is just 1. So how many y's are we left with in the numerator? How do we write that with an exponent? Y to the 3rd. In the denominator, how many y's are left? We don't have any y's left, we just have the number 1. So what's our final answer? Y to the 3rd. Again, we can look back at the original problem, y to the 4th divided by y. Remember, y means y to the 1st. We're basically taking 1 y away from these 4 y's, canceling it with one of the 4 y's, and we're left with 3 y's. So now I'd like you to pause the video and try this next problem. I want you to write everything out, do your canceling, and then see if you can figure out what it equals when you simplify. And then we're going to talk about the property beneath it. So I ended up with the 3 x's, the 6 y's in the numerator, the 2 x's and the 4 y's in the denominator, and I'm going to cancel x's to equal 1. And then cancel any y's I can, so that y divided by y is 1. And let's see what we have left. Hopefully you ended up with 1x and 2 y's in the numerator, and just a bunch of 1's being multiplied in the denominator. So that's x times y squared in the numerator. So again, a simple way to think about this, so you don't have to write it all out, is we're taking these two x's in the denominator and we're going to take them out and cancel them with two of the x's in the numerator, so we're left with 1x. We're going to take the 4 y's in the denominator and cancel with 4 of the y's in the numerator, so we're left with 2 y's. So we're left with x times y squared. An even simpler way to do these problems, based on understanding what I've just showed you, is to use the property listed here. This property shows you that when you have the same base, again we're working with same bases, you're going to subtract the exponents, the numerator's exponent minus the denominator's exponent. And the reason we subtract is because of this idea of canceling out, this idea that here I had two x's and I canceled those with 2 of the x's in the numerator, so I was left with 1x, is really me saying those 3 x's in the numerator minus those 2 x's in the denominator gave me 1x in the numerator. Same thing with the y's. Those 6 x's in the numerator were canceled by 4 of the, the 6 y's in the numerator were canceled by 4 of the y's in the denominator. So we were left with 2 y's in the numerator. So it's because of this canceling that we use subtraction. So when same bases are divided, keep the base and subtract the exponent.